The spherical law of cosines can be derived as follows. A straight path on a spherical surface follows a great circle, which is a circle with the same diameter as the sphere. That means that the sides of a spherical triangle are circular arcs, not line segments. The vertices of our spherical triangle are a pole and our two observation locations. The sides connecting each observation location to the pole are the complements of their latitudes. Finally, you can also construct this right triangle within the cross-section of the sphere. For the sake of convention, let the W subscript be for an observer to the west and the E subscript refer to an observer to the east. Neither observer is more important, and it wouldn't be right for one of them to be observer 1 or A or something that implies primacy. The angle between these sides is the longitude between observers, which will be labeled L. Two of these sides lay in a plane tangent to the pole, and the law of cosines gives an expression for the remaining side. A similar construction can be made for the plane that contains the great circle connecting the observers. That's the same segment, but this time it's opposite the angle that subtends the arc that connects the observers. Let's call that angle D. If you apply the law of cosines to this triangle, you get this expression for the third side. So, from each triangle, we have two expressions for the same side. Since these are equal, we have this equation to simplify. Square both sides. Subtract everything from the left. These terms can both be simplified with a Pythagorean identity. Divide both sides by 2. Now solve for cosine of D. Add secant phi w, secant phi e, cosine d to both sides. Divide both sides by secant phi w, secant phi e, and simplify. This gives us an expression for the spherical law of cosines with the notation in this experiment. We now have two expressions for the same distance, a distance measurement from Google Earth and the circular arc subtended by angle D. Substitute measured values and you have a value for the radius of Earth. Compare it to the established mean value of 6,370 kilometers.